So our next speaker is our very own Dr. Jen Heldmann. And Jen is going to be giving us a much anticipated update on what's going on at Mars right now. So Jen.
Well, while they pull all the slides up, thank you all for coming here to NASA Ames, and thanks to those of you that are online watching this as well. I'm Dr. Jen Heldmann, and I work here at NASA Ames, and I work in the planetary sciences world, and I study the moon. I love the moon. I know this is International Observe the Moon Night, but I also study Mars. And you've probably heard in the news there's been a lot of activity going on the planet Mars, and so I just wanted to give you a brief overview, talk about some of the spacecraft that are there, show you some of my favorite pictures, and let you know the status on some of the missions. So did you know that there are quite a few spacecraft at Mars right now? And so here's a listing of some of them. We have orbiters that are going around Mars, satellites going around taking data, the Mars Reconnaissance Orbiter and Mars Odyssey. Those are NASA missions. There's also Mars Express, which is an orbiter that's European Space Agency has sent to Mars. And then, of course, NASA has a few rovers on the surface of Mars right now. We have the Mars Exploration rovers, Spirit and Opportunity. Opportunity is still alive and kicking. And there's also the Curiosity Rover, which just landed in August, which many of us were here for, right here in the same place at Ames to watch. So I just want to give you a few highlights of what's been going on in the science world of Mars. What have we been learning lately? And here's something that came out this month in September from the Mars Reconnaissance Orbiter. South Pole carbon dioxide snow on Mars. So we have snow here on Earth, not in the Bay Area, but in a lot of other places. And so we have water ice that comes down to the ground. We have rain and we have snow, and it's water. We have that on Mars too, and we knew that from one of the previous spacecraft that we sent, the Mars Phoenix. And now we have data showing there's carbon dioxide snow. So instead of H2O, which is water, we have CO2, carbon dioxide snowing on Mars. And so that was a very new discovery, which was a pretty neat thing that we figured out. I think this picture is really cool too. This is from the Mars Reconnaissance Orbiter. Basically, the Mars Reconnaissance Orbiter is like a spy satellite that's at Mars. It takes these ultra high resolution pictures, and here's one of the pictures it took. This is a Martian dust devil in the northern plains of Mars in a place called Amazonas Planitia, and it's 12 miles high. So I am glad that we were not there, but we were just watching from above, because that is a pretty serious dust cloud. Here's just a pretty picture. This is from the Mars Odyssey spacecraft, and these are sand dunes. And there are a lot of sand dunes on Mars. And some of you may have gone to sand dunes on Earth, and you can climb up them and you can run down them. But when you see them from above, they're really quite spectacular. And there are all sorts of different patterns that you can see. There's different colors in the different sand dunes as well. And so if you go online, you can look up lots and lots and lots of pictures of sand dunes on Mars. Here's another picture from Mars Odyssey. This is one of my favorite valleys on Mars. This is Dow Vallis. And you can see in the picture, it looks like a big river channel that was flowing down on Mars. And so you can imagine one day, several billion years in the past, where there's water flowing through these channels. And there are a lot of channels like that on Mars, where we see the evidence that there used to be lots of liquid water flowing on Mars. Today, Mars is pretty dry. There's really not much liquid water, if any, on the surface today. Everything is all dried up or frozen. And so we see the remnants of that ancient fluvial or water-based activity. Here's more evidence. This is also from Mars Odyssey. More evidence of water ice. So this is a map that was made by one of the instruments measuring neutrons. And as scientists, we can look at these maps and we can figure out how much water ice is in the ground. And so that's what this map is showing us. You see near the North Pole of Mars at the top, it's very blue. And near the South Pole of Mars, it's also very blue. And what that means is that there's water ice in the ground. In the upper about 1 meter or so, there's water ice in there. So we know that there's ice frozen on Mars. Here's a really spectacular picture. This is from the European Space Agency spacecraft, the Mars Express, which is a satellite in orbit. And here's a big crater. So you see the big circle. It's a big hole in the ground. And in the middle of it, you see a big white patch. And we know now that that white patch is a big piece of ice. So to me, it looks like a big skating rink on Mars. And you can see on the edges, you see frost. You see water frost on the sides of the crater. So I would say that this is our candidate Olympic site on Mars for about the 2050 range or so after we get humans there. Here are some really nice pictures too. So this is some more of that water-based activity I talked about. Lots of canyons and valleys on Mars that were formed by flowing water several billion years ago. Here's one of those chasms on Mars, and the top picture is showing looking straight down. So it sort of reminds me of looking down on something like the Grand Canyon, although these are much, much bigger in scale, way bigger than the Grand Canyon. And then if you look in the bottom, you see a perspective image where you can actually, if you go online, you can find these and you can fly yourself through these canyons. And it's really great because you can see the walls of the canyons and the curves, and you can just imagine as you're going down on a boat or water flowing down through these big, big channels that have carved out the Martian surface. Okay, so those are lots of pictures from orbit, looking down on Mars, and we've learned a lot, and there's a lot more I could tell you. I urge you to go online. There's a lot of good information on the websites. But let's go down to the ground. We have rovers on the ground, and we have the Mars Exploration Rovers. So a few years ago, we had Spirit and Opportunity that landed on Mars. And this is the place where Spirit landed. This is the landing site of Spirit in Gusev crater. And you look at it, you see this broad plain, you see rocks that are strewn on the plain, they're kind of dark, looking blackish. You see a lot of dust. And so just from this information, we know right away, well, we knew that the rock type is basalt. That's a geologist term. And basically what it means, it was formed by volcanoes. So we know that this area had a volcanic origin. And the dust is magnetic, and there's a mineral called magnetite in that dust. So just from getting on the ground and getting some of that data, we can learn a lot about the geologic history of that place where the rover is. The other rover was the Opportunity rover, and it made a lot of scientific discoveries. Let's talk about a couple. One, you see these little circles that are over there on the ground. We called those blueberries because that's about the size that they were. And what they were these little rocks that are made up of a lot of iron. And we know that these rocks only form in water. So we knew, based on seeing that picture and identifying what those were, that where Opportunity landed must have had water activity probably a few billion years in the past. So then, Spirit keeps trucking on and takes this picture just this month, in September. And it looks pretty much like blueberries, doesn't it? But they're not. They're totally different. They're not made of iron. They don't have the same minerals. They don't have the same structures. They're a totally different thing. We still don't know what they are. And that's one of the mysteries, and that's why we do science, is because we go and we have these discoveries, and now we have to figure out, okay, what is this picture trying to tell us about this place on Mars? So stay tuned, because I don't have an answer yet. Here's a picture. I thought this was a nice picture of Opportunity looking down on itself. And this is a few years into the mission. So you can see it's really dusty. So Opportunity has gotten covered in dust. We know that Mars is dusty. You saw pictures of a big dust devil. There are global dust storms that happen on Mars. You saw at the other landing site that there's dust covering those rocks. And so it's no surprise that dust also covers the spacecraft. And now we have the proof because we took a picture of it. So where are Spirit and Opportunity now? Well, Spirit had its last communication back in March of 2010, so its mission is officially done, and it drove a total of 4.8 miles on the surface of Mars. Opportunity is still going. Remember, these rovers launched in 2004, and they were designed to operate for 90 days. And now it's like 8.5 years later, and Opportunity is still going. So that's pretty amazing. That's some pretty incredible engineering and operations. And Opportunity has gone almost 22 miles so far, so stay tuned. That just landed on Mars. Many of us saw the Curiosity landing, either here or online. And Curiosity was sent to Mars to answer this fundamental question: could Mars have once harbored life? And so it launched in November of 2011, and it just landed August 6, 2012. And what I want to do is show you a quick video of how that thing landed, because now we can come to you and say it worked. Before, we didn't know if it was going to work. We were hoping it was going to work, had good engineering, we're confident that it would work. And now if we show you a video, because I think that this never gets old. Okay, so here is the lander coming in. It's got its heat shield on because you're coming into the Martian atmosphere really, really fast, so it gets really, really hot. It popped out a parachute. Parachute helps slow it down to subsonic speeds. Then you jettison that heat shield, so let that drop to the surface, and now you've got the rover itself exposed. The legs start to come down, it's still in that back shell, and what's going to happen is the rover pops out, pops away from the back shell, and now it's got basically this jetpack. right? It's got these retro rockets that are attached to the rover to help slow it down as it comes down towards the lunar surface, or towards the Martian surface, sorry. Slow yourself down, and as you get closer and closer to the surface, lower the rover down on some cables, right? Still have the retro rockets going. And then what's going to happen is once this rover comes down and hits Mars, touches down with the wheels, as soon as you have that load gone, the cables break off, the jetpack goes and flies away because you don't want it to crash on the rover you just safely landed. So it goes away, and now we're left with the very nice Curiosity rover on the Martian surface, and it goes through a series of checkouts. First thing, it raises up the mast cam, what we call it. There's a camera on top of that mast. That's where we got some of the great pictures that I will show you in a few minutes. And it goes through and looks at its horizon and looks at its surroundings. And I'll show you some of the pictures that Curiosity actually took. And the rover has started roving. And just for a sense of scale, that rover is about 4 times bigger than the K-10 that you saw here at Ames deploying that Kapton. So about 4 times bigger than the rover that's sitting out here right now. That's a big rover to land on Mars. And it's remarkable, a remarkable feat of engineering that it actually all worked. And the rover is safely on Mars right now. And you can see leaving some of the tracks in the dirt. I'm going to show you some of the pictures of the actual tracks from Mars that the rover has left. And now it goes about its mission and carries on. So that was a very spectacular landing, and that was a nice animation of the landing. But now that we've actually done it, and the rover has actually made it to the surface of Mars, why don't we see what it actually looked like from the rover's perspective? Because guess what? There was a camera looking down as the rover went through that whole entire sequence. So what I want to show you now is the actual data of the landing. So here you've got, this is the heat shield that just dropped away, and it's going to fall back towards the Martian surface. And now you've got just the rover exposed, like we just saw it, and we're kind of swinging back and forth because you're on a parachute, and you're kind of going back and forth. You're seeing the Martian surface that you're coming towards right now. And this is actually in real time. This is from actual data from the descent camera, and it's been interpolated to go up to 30 frames per second. And you can see you're coming down, there's sand dunes, that's what those dark features are. So I showed you some pictures of sand dunes earlier, so you should be able to recognize what that pattern actually looks like. And you're descending down. Now remember, while all this is happening, you're coming down, you had your parachute come out. When the speed changes a little bit, remember that we go to the jetpack, and the jetpack lowers it down towards the Martian surface. So this gives us a very good idea of where we landed and what the terrain was like, and lets us pinpoint where we went. And as we come down and we get closer and closer, what you're going to see eventually when we get down towards the surface, it happens pretty quickly because this is in real time. You're going to see a wheel come into view in the bottom of the frame. You'll see some dust get kicked up from those retro rockets, and then you'll see us safely on Mars. So here we are coming down towards, we're going to land just to the side of those sand dunes. All right, now you're coming in closer. Almost down. You've got your dust being kicked up. There comes the wheel in the side. And then hopefully you land, and there you are on the surface of Mars. So I think that's a really impressive video. That was the data that was taken from the spacecraft. And then you can see there's some scour marks that are actually on the ground from those retro rockets that lowered the rover down to the surface. And then you look out and you can see on the horizon, as we pan up a little bit, there's a mountain in the background, or a great big hill. And that's called Mount Sharp. And that's the whole reason that Curiosity went to this place. I'm going to show you some pictures of Mount Sharp, but basically it's a big layered mountain in the middle of this crater. And we went there because those layers are a geologist's dream. Those layers are telling us the geologic history of that place. And that rover is going to drive up those layers and read that geologic record over the next couple of years. Okay, so I just want to show you, to close up, I just want to show you a few pictures from Curiosity. This is a picture that was taken by the Mars Reconnaissance Orbiter. This is amazing. So here, there's a spacecraft in orbit took a picture of Curiosity landing, and there's the parachute, and there's the spacecraft on the end of the parachute as it's descending down. So we've got pictures from the rover, and we've also got pictures from orbit showing that landing. Here is where we went. This is GALE crater on Mars, and so the rover landed in the yellow spot right over there, and there's Mount Sharp, and that's where we're going to go. We're going to drive up to Mount Sharp. And the difference in elevation between where the rover landed and the top of the mountain is about 3 miles or 5 kilometers. So we've got some driving to do. I'm going to show you how much driving we've done. Here's where we've gone so far as of just a couple days ago. So the Bradbury landing site, you can see it's a little discolored because there was some rocket activity going on there at the landing site. And then the different numbers are the different days. Sols are basically day on Mars. And so we've driven that far, and the goal we're trying to get to is this Glenelg place over here. So it looks like we've gone kind of far, but really we haven't gone as far as we're going to go, because there's a landing site way up there in green. We're trying to get to the blue. We're not quite at that blue right next to the landing site yet. And then the blue dot over by the circle, that's the base of Mount Sharp. So we've got a ways to travel. This is a mission that is slated to be at least 2 years long, and we need that because we need to drive. You can see the dark, there's the sand dunes that we saw. You need to drive down the length of those and then start climbing up Mount Sharp. When the rover looks out, here's a picture of Mount Sharp. I could have fooled you and told you this was Arizona or Utah, because that's what it looks like to me. But you can see those layers that I was telling you about. That's why we went there. We want to go climb those layers and see what the history of this place was. We went here because there's minerals that we saw from orbit that really only form in water. So we think that there used to be a lot of water activity going on here. It's obviously very dry in this place right now, but in the past there was something else going on, and the story is told in the rocks. So we're going to go read that story. Here's a self-portrait of Curiosity from the surface of Mars. It's a little fuzzy because this was taken with a camera that still had its dust cover on. It hadn't popped the dust cover off yet, but I think it looks very much like a little person saying hi. So you can verify that we're actually on Mars. I just wanted to throw this in here to show the complexity of this mission. This is one instrument that's on this rover. There are 10 instruments on there, not to mention the entire rover, which is very complicated in itself. And so this is the alpha particle X-ray spectrometer. And so you can see there's a tremendous amount of engineering that's gone into putting these instruments on and making this rover work. And so it's pretty amazing. And then the science that we get out is going to be totally well worth it, I think. I thought this was interesting too. So it's a penny, and it's a penny that's on Mars. So it's a very common thing in geology when you're out in the field to bring something with a known scale so that when you take a picture of a rock, you know how big it was. So we often put a coin next to the rock or a rock hammer so we know sort of how big things were. And so as an ode to that field geologist, there's a penny, there's 1 cent that was flown on the Mars Science Lab Curiosity Rover. And what it's doing is actually showing us dust that got kicked up. And so we can actually do dust measurements and study how big are these dust grains, and we can watch how they move. So there's a couple of different dust grains that are pointed out. So when you go look at your penny at home, see if you could see specks that are that small. That's how good that camera is. And there's some of the tracks. So we started driving successfully. And so you can see the rover tracks as we progress down. You can see the wheels down in the bottom. And so everything's working quite well. There's also a very interesting event that just happened not too long ago, earlier this month. There was a transit of Phobos. Phobos is one of the moons of Mars. Mars has 2 moons, and it went over the sun, and it blocked out a little part of the sun. And so the rover from the ground went up, looked up, and took a picture of the sun and saw Mars's moon going across the face of the sun. And so that was pretty neat, so I wanted to show you that. So that's my quick update of Mars. I'd be happy to talk to folks afterwards. I think we're going to get back to talking about the moon, but I hope that you enjoyed seeing some of my favorite pictures that we have from Mars.
Jen, thank you so much for a wonderful talk. It really occurs to me sometimes what an amazing age of discovery that we're in right now. We're seeing these places for the first time. Humans aren't there yet, but our robotic emissaries are, and they're doing incredible things. And all those kids who in the audience that I called out earlier, it's you guys that might be the ones to first set human footprints on Mars, and maybe go to that Olympics that Jen is talking about in 2050 or so. So let's plan on it. One other thing that I wanted to mention as well, first of all, our sister center down at the Jet Propulsion Laboratory, did an absolutely amazing job, as we all know, landing Curiosity. Ames actually did have and does have an important ongoing role with Curiosity as well. We actually tested some of the parachutes that were used and solved a tough technical problem at the time several years ago during development of the mission. And one of the major experiments on the rover is actually the principal scientist is here at Ames too. So we're very proud to be participating in this.